What's up, people? Alright, so basically we have a recursive function here, and it takes an integer as a parameter, and it also returns an integer. That's going to be kind of important. So it can return itself, basically, which is good for recursion. Anyways, we have 4 conditions here: if, else, if, else, if, else. 2 of them are base cases. The first one is actually never used at all because 0 will only happen if it's negative, and we're not working with negative numbers. So it's not really needed, but I like to be kind of complete. Anyways, the second one is kind of the most important because that's the actual base case you want to hit, and you'll hit the most with positive numbers. They'll return 2, and that's pretty simple. This is the first recursive return statement, which will return itself, except it'll be divided by 2, and it only happens when it's an even number. If you don't know that x mod 2 equals 0, basically if you get a remainder of 0 when divided by 2, it's even. And I added +1 for explanation later. And then this is for odd numbers, and it's basically the same thing, except it has +1 because I kind of want to work with even numbers, so I don't have to explain a lot about truncating and all that. Anyways, so let's start tracing. Let's say we have a function called, so actually let me do it a little more over. There we go. We call add num of 8. Alright, so we call that, and we'll set it equal to int something. I don't know, that's spelled wrong, but I don't care. So that's called, and it calls the method with an 8. I like to write the function when I'm writing shorthand, f of 8. It's the function. You could say add num of 8, but really writing, you want to be as brief as possible. So then we go back up here. One sec, let me drag this back up. And we see that first condition is not satisfied, second condition is not satisfied, third condition, it is even. So it will return, it's supposed to return add num of x over 2. So add num of x over 2, or f of x over 2, which is 8 over 2 in this case. And we'll just simplify that to 4. Plus, again, f of 4 plus 1. And this is what it will return, but it needs to define what is f of 4. Well, I'm glad you asked. F of 4, again, the only condition that's satisfied is the third one, because f of 4 is even. So we again say f of 4 over 2, which is 2, plus f of 2 plus 1. And then we have to say, well, what's f of 2? Again, I'm glad you asked. F of 2 is equal to f of 1, because 2 over 2 is 1, plus f of 1 plus 1. And then finally, f of 1. Before you'd be like, oh well, that's just 1 over 2 plus 1 over 2, and no, that's the scroll up here if you can't see that. That is the else if x equals 1, and it returns 2. That's the base case. As a recursive function, everything has to go to its base case in the end. And so does this. This goes to 2. Now once you get to the base case, that's when you start working your way back up to like these ones. So you got to your base case. You know what f of 1 is. F of 1 is 2. So f of 2, let me move over here for you. There we go. F of 2, before we said it's equal to f of 1, which is 2, plus another f of 1, which is 2, and then plus 1. That equals 5. We know f of 4 is defined as, well, f of 2 plus f of 2 plus 1, as we saw right over there, right here. So that means it's going to be 5 plus 5 plus 1 equals 11. And finally, f of 8, the original call. And as we know, it's equal to f of 4 plus f of 4 plus 1. So, equal to 11 plus 11 plus 1, which equals 22. 23. Bad math there. And so that's it. You just traced what would happen when you plug it into add num. So let's kind of review what we did there. And though this is like kind of a horrible method, because like when would you ever use this? Probably never. It does give you a basic structure of what you want to do. What you want to do when you trace these recursive functions, either for debugging or for a test, you want to start with what you gave, f of 8, and what that should produce, which is f of 4 plus f of 4. And that'll work down to its base case. And then once it gets to the base case, that's when it starts returning statements. It goes back up the recursive stack, as it's called. And this is actually called recurrent. It's when you take a function and it's defined by another function, by the function smaller, I guess is what you'd say. That's called recurrence. You learn that in discrete mathematics, I guess. And that's it. That's how I trace, at least. You might do it a different way, but most people will have the given parameters in there, and they will have what it produces, and it will always work down to the base case. So yeah, that's it.